Okay, welcome back to the new video about the acceleration. And now I'm doing problem number 26, and it says a car can go from 0 to 100 kilometers per hour in 5 seconds, assuming that it could maintain the same acceleration at higher speeds. How long would it take the car to go from 0 to 120 kilometers per hour? So here I just need to use one of the equations of motion that we learned about, which says V final equal to V initial plus AT. Now the V final is 100 and V initial is 0. And the acceleration is unknown and the time is 5 seconds. That can give me the acceleration, which is 20. But you guys should be careful here, like you should know the unit, because here I have the velocity in kilometers per hour and the time in second. So that's why the acceleration is 20 kilometers per hour second. Now the question is, do I need to convert this into kilometers per hour squared or meter per second squared? Indeed, no, you don't have to, because you can see in the second part when we try to find the time to go from 0 to 120, if I put the velocity equals to the final velocity 120, the initial velocity is 0, the acceleration is 20 kilometers per hour second, then if I calculate the time, I will get the time in seconds. So there's no need to keep converting back and forth like this. So just use the velocity in kilometers per hour and use the time in second. Then you will end up having the time 6 seconds, and the answer is A. Now the next problem 27 is about a graph, and I can see it's still a speed versus time graph. So it says that the speed versus time for a particle moving in a straight line is represented in the figure below. What is the particle acceleration at time equals to 3 seconds? So here we need to find the acceleration. Now remember that in maybe the last few problems I used to have speed time graph, but I was asked to find the position or the distance covered. But now I'm asked to find the acceleration. If you want to find the acceleration, then you must find the slope of the graph. So of course, if you want to find at 3 seconds, then you need to find the slope of this part of the graph. So what you need to do is to just find 2 points. Let's say 4 and 0, and then 4 has 2 and 0 has 4. So it's a 4 minus 0 divided by 2 minus 4. So it's a negative 2 meter per second squared, which means that the acceleration in this case is 2 meter per second squared, and because it's a negative slope, so it means that this object is slowing down. Now we can move on to the problem number 28, and it says a ball is thrown straight up in the air, for which situation are both instantaneous velocity and the acceleration is 0. And the answer here is none of the following. And if you check the different options, you will remember, of course, from your studies that if you throw an object straight up, then the velocity starts to decrease until it becomes 0 at the highest point. But the question is, if there is no air resistance, of course, does the acceleration change? And the answer is no. The acceleration will not change. It remains 9.8 meter per second squared. So we have to be very careful about this. So yes, the instantaneous velocity could be 0, but the acceleration will not equal to 0 because it stays as 9.8 meter per second squared. Now let's check the problem number 29. And it says a car can go from 0 to 100 km per hour in 12 seconds. A second car is capable of twice the acceleration of the first car. Assuming that it could maintain the same acceleration at higher speed, how much time will the second car take to go from 0 to 200 kilometers per hour? So in this case, I have two cars. I have the first car, then I have the second car. Now my job is to first find the acceleration of the first car. So I have v equals to v0 plus at. So final velocity is 100, initial velocity is 0, is the acceleration, and 12 seconds is the time. Then you can find the acceleration. Now use this for the second car. V equals to V0 plus AT. Now the final velocity is 200, initial velocity is 0. Then we have the acceleration must be twice this acceleration, because they said that the second car has twice the acceleration. So we must multiply this number by 2. So that's why I'm multiplying by 2 here. Then multiplying by the time. Then I solve for the time, and I got 12 seconds. And now we move on to the problem number 30. And it says that the figure below describes the speed of an object as a function of time during 8 seconds. What can you conclude about the acceleration of the object? So here you can see that we have a speed-time graph. And of course, as you guys have a speed-time graph, and if you want to find the acceleration, then you need to find the slope of the line. And as you may see here, that the slope does not change. The slope is the same because it's a straight line, so the slope does not change. So what I'm expecting is the acceleration remains constant. So the correct answer is A. Now we can move on to number 31, and it says that a car whose acceleration is constant reached a speed of 80 kilometers per hour in 20 seconds starting from rest. How much more time is required for it to reach the speed of 130 kilometers per hour? So let's think about it. First thing, we need to find the acceleration. So the first thing, we can use this equation that says v final equal to v initial plus at. Now what is the v final? It's at. And what is the v initial? It says it started from rest, so the initial velocity is 0, plus acceleration is unknown, multiplied by 20 seconds, which is the time. That gives us the acceleration 4 kilometers per hour second. Again, do I need to convert this into kilometers per hour squared or meter per second squared? The answer is no. You can just save your time and just use the same acceleration again. And what will happen if the final velocity now becomes 130? So it's a v equal to v0 plus at. So it's a 130 equal to 0 plus 4, which is the acceleration multiplied by the time. Now you can find the time. But the time here is how much? It's a 35.5 seconds. But remember that they are asking us of how much more time is required. So we need to know the additional time from the first part. So the first part of the time is 20 seconds, the second part is 32.5 seconds, so the additional time is 12.5 seconds. Next question is a conceptual question, and it says, which of the following statements about centripetal acceleration is correct? And this is the correct answer because in a centripetal motion, the object moves in a circle such that the acceleration is always toward the center and the velocity is a tangent to the motion. So you can see this is a tangent and this is a radius. So the angle between them should be 90 degrees. That what does the word perpendicular mean, right? It means 90 degrees. So A is the correct answer here. We can move on now to 33, and it says two balls are at the same height and released at the same time. One ball is dropped and hits the ground 3 seconds later. The other initially moves horizontally at 10 meters per second as shown in the figure below. How far does the second ball travel horizontally before it hits the ground? So now these two balls, one of them was thrown. The second one was drop. Drop means it started with, or the initial velocity is 0. This one is thrown with a velocity of 10 meter per second. Now the question is, which one will reach the ground first? And the answer is both balls will reach the ground exactly at the same time. So if I know the time of one of the two balls, I can use it for the other ball. And we already know that the drop ball hit the ground after 3 seconds. So just take this time, multiply by the horizontal velocity, it gives you the horizontal distance, because this distance, which we call range in the projectile motion, equals to v times t. Now this v is the horizontal velocity multiplied by the time, so it's a 10 times 3, that will be 30 meters. Now next question 34, it says that a student stands at the edge of a cliff and throws a stone horizontally over the edge with a speed of 18 meters per second. The cliff is 50 meters above a flat horizontal beach as shown in the figure below. How far from the base of the cliff does the ball hit the beach? And like this is the picture of the problem. So we have a cliff, and the height of this cliff is 50 meters, and someone throws an object at a horizontal velocity of 18 meters per second. So again, in a projectile motion, if they tell you the velocity is horizontal, it means that the vertical component is 0 and the horizontal component in this case is 80 meters per second. So my first goal is to find how long does it take the ball to hit the ground. So I will just use this equation that we have seen so many times before. It says that the height d or h equals to v initial t plus half g t squared. Now the height here is 50 meters and the initial velocity is 0. Now why it's 0? Because I'm not taking the horizontal component, I'm taking the vertical component, and the vertical component is 0 plus half times 9.8 times t squared. That gives me the time that it takes the ball to hit the ground, which is 3.19 seconds. Now, if I want to know the range, which is where the ball will hit the ground, just use r equals to v times t. Now this v is the horizontal velocity, which is 18 meters per second, multiplied by 3.19 seconds. That gives you the range, which is 57.8 meters. Now we move on to the next problem, which is number 35. And it says in this figure, we see the speed as a function of time. I have seen that so many times. What is the acceleration of the object as it is slowing down? So when they say the object is slowing down, it means that we have a negative slope. As you can see here, this is the only location where we have a negative slope. So I just want to find the slope here, so I just take any 2 points and then I take the difference in y and the difference in x. So I have 10 minus 2, for example, and 10 has an x value of 2 and 2 has an x value of 6. So it's a 10 minus 2 divided by 2 minus 6, it becomes a negative 2 meters per second squared. So that is the slope, and that's also the acceleration. Now let's move on to number 36. And it says that a car is traveling due west in 20 meters per second. What is the velocity of the car after 37 seconds if it accelerates, if its acceleration is 1.0 meter per second squared due west? So that's pretty straightforward. So I'll just use v final equal to v initial plus at. Now the v initial is 20, but remember it is west, and west means minus plus a, the acceleration is 1. Now is it east or west? It is east, so it's plus. Multiplied by the time, which is 37, so I have minus 20 plus 37, that would be 17 meters per second. Now let's look at the next question, which is Question number 37. It says that three balls of different masses are thrown horizontally from the same height at the same time with different initial speeds as shown in the figure below, where the speeds are represented by the length of the arrow. Which ball will reach the ground first? Okay, so I guess we have seen something like that before. And you have these three balls and all of them have been thrown horizontally. It means that they have a horizontal velocity. But from the size of the arrow, you can tell that this horizontal velocity is larger than this, is larger than that. But the question is, what will happen? Which ball will hit the ground first? Now, you have to remember that the time needed for the ball to reach the ground does not depend on the horizontal velocity. It depends only on the vertical velocity. And guess what? What is the vertical velocity for all these balls? Yeah, it is zero. So because all of them are having a vertical velocity of zero, then they would all reach at the same time, and the answer here is A. Next question, number 38, it says that a car is moving with a constant speed in a circular track as shown in the figure below. In which direction will the acceleration be at point A? So they basically ask us, you have this car that moves in a circle. If you pick this point A, what will be the direction of the acceleration? Now remember, whenever you move in a circle, then you have a centripetal acceleration, and the acceleration is always pointing toward the center of the motion. So from A toward the center of the motion, that will be towards the north. I guess 39 is another question about projectile motion. It says that a toy car, as in the figure below, runs off the edge of a table that is 1.225 meters high. The car lands 0.400 meters from the base of the table. How long does it take? We need to find the time. Now remember, to find the time, all what you need is the horizontal velocity. You don't need, the vertical velocity, you don't need the horizontal velocity. So just use d equals to v initial t plus half gt squared. Now what is the height? It's a 1.225. The initial velocity is 0 plus half times 9.8 times t squared. Then t will be about half a second, and the answer again is A. Next question with us here, it says that a cyclist traveling at 23 meters per second north applied the brakes, means he slows or she slows down, producing an acceleration of 7.2 meters per second squared. That should be minus because it's south. What is the motor cyclist velocity after 2.5 seconds? So here I again use v final equal to v initial plus at. Now what's the v initial? It is 23. Is it plus or minus? It is plus because it's north. Then the acceleration is minus 7.2 meters per second squared because it is minus multiplied by 2.5 seconds. Now just subtract these two guys from each other, you will end up with 5 meters per second, and because it's plus, so I should use north. Now let's look at this graph. It says that the figure below represents the speed time graph for the motion of a vehicle during the 7 minutes trip. You can see here that the time is 7 minutes. Which of the following statement is correct about the motion of this vehicle? The correct answer here is A, which says that the acceleration of the vehicle has changed several times. And how do I know this? Because here you can see the slope is changing, speeding up, same speed, slowing down, zero speed means stop, and then speeding up, same speed, slowing down. So that gives you an indication that the acceleration had changed. Of course, I cannot pick B because here it says the acceleration never changed, which is not true. And C, the vehicle has never accelerated again, which is not true because here we can see the acceleration, here you can also see the acceleration. and the vehicle has never stopped, and again no, because it stopped between 2 and 3 minutes. Number 42, it says the rock is dropped at the same instant that a ball at the same height is thrown horizontally. Which of the following statement is correct? Now remember that here you have two objects. One of them is dropped, the other one is thrown. They will both reach at the same time, but the one that is thrown horizontally must reach at a higher velocity. And why is that? Because the one that was thrown is having a vertical and a horizontal velocity. The velocity would be the square root of the v horizontal squared plus the v vertical squared. When the other one, which was dropped, it should only have the vertical velocity, so it must be less than the other one. Now let's check number 43, and it says that a ball thrown upward with an initial velocity of 8.3 meter per second, air resistance is negligible. How long will it take to reach the maximum height? Now we learned before that maximum height means the final velocity equals to a 0. So I can just use the equation that you guys see in front of you that say that the v final equals to the v initial plus gt. And the v final is 0, the v initial is 8.3. You move against the gravity, then put a negative sign, then multiply by time, and then you just solve for the time, and then you will get 8.47 sec, which is the first choice. Number 44 says that a cyclist starts at rest and accelerates at 0.5 meter per second squared north for 40 seconds. What is the cyclist's final velocity? Again, that's very straightforward. I can just use v final equals to v initial plus at. The v initial is 0 and the acceleration is 0.5 meter per second squared. It's north, so it's plus, and then the time is 40 seconds, and then multiply 40 times half, that would be 20 meter per second, and it's plus, so it must be north. So I must use, I don't have to pick B, the answer should be A. And next question says, in which of the following examples is the motion of the car not accelerate? And here the answer is a car climbs a steep hill on a straight road at a constant speed. So it doesn't matter if you're moving on a straight road or a steep road, as long as you can maintain a constant speed, it means that you are not accelerating. That means that the choice A is the most correct choice. Now let's move on to 46, and it says that a car whose brakes can produce an acceleration of negative 6.0 meter per second squared is traveling at 30 meters per second. When its brakes are applied, what is the car's speed 2.3 seconds later? So I have v final equal to v initial plus at. What is the v initial? It's 30 meters per second. And what's the acceleration? That's a negative 6 multiplied by the time, which is 2.3 seconds, as indicated here in the problem. And then remember, the acceleration must be negative, must be minus. You will end up with 16.2 meters per second. So I guess 16 will be the closest answer here. Now move on to 47, and it says that a rock is dropped at the same instant that the ball at the same height is thrown horizontally. Which of the following statement is correct? I guess this is the repeated question, like 42, and we have already answered that the ball, the horizontal one, should reach at a higher velocity. As we mentioned before, they both reach at the same time, but the one that is thrown horizontally should reach at a higher velocity. Now we move on to 48, and it says that the figure below represents the speed time graph for the motion of the vehicle during 7 minutes trip. You have 7 minutes trip. How many times the vehicle had decelerated? And the word decelerated means that it slows down. So I have acceleration means speeds up, deceleration means to slow down. And this will happen when you have a negative slope. So I have 1, 2, 3 negative slopes, right? And then the answer should be A, because A is 3. Now let's move on to 49, and it says which best describe why projectile move in a curved path. Like why if you throw a projectile, why it does not fall like this or like this, it moves in a curve, it moves in a curved path. And of course this is because there is the effect of gravity. So you have a horizontal motion, but you also have a vertical motion. You have both kind of motions, and that's what makes it move in a curved path. And number 50, it says that the figure below represents the speed time graph for the motion of a vehicle during a 7-minute trip. Which of the following statement is correct about the motion of this vehicle? So let's see, what do we have here about the options? And the correct answer is the acceleration of the vehicle has changed several times, and you can see of course the acceleration is keep changing. And why is that? Because the slope is different, right? Because the slope here indicates the acceleration, and as you may see the acceleration had changed several times. But if I say the vehicle has never stopped, no, of course stopped here between 2 and 3. If I say the vehicle has never accelerated, no, it did accelerate, and so on. So the correct answer here is A. And now we move on to 51, and it says that a car goes from rest to a velocity of 108 km per hour in 10 seconds. What is the acceleration? That is very straightforward. So it's a v final equal to v initial plus at. And here I have 108 kilometers per hour, and the time is at 10 seconds. I want to find the acceleration. Now, if you remember, I told you in one of the previous problems, maybe a couple of them, don't convert kilometers per hour to meters per second because it's useless. But here, because they want us to find the answer in meter per second squared, so we must convert kilometers per hour to meters per second. That's why I need to multiply 108 times 1000 to convert from kilometers to meters. Then I need to divide it by this is probably not correct. So I need to have this 100. Yeah, this is correct. I have to multiply 108 times 1000 to convert from kilometers to meters. Then I need to multiply the denominator, which is hours, by 60 times 60, which is 3600, to convert from hours to seconds. And then I put the time here in seconds. So this 108 gives me 30 meters per second. So 30 divided by 10, that would be 3 meters per second squared. Now next question says that if you drop a baseball from a height of 1.5 meters, it will hit the ground in about 0.55 seconds. If you throw a baseball horizontally with the same speed, with a speed of 30 meters per second from the same height, how long will it take the ball to hit the ground? So as we mentioned before, that the time depends on only the vertical motion, not the horizontal motion. So it doesn't matter if you throw it with 30 or with 40 meters per second, that doesn't matter. So both balls should reach exactly at the same time. So the correct answer here is A. And for the problem number 53, it says that two balls are at the same height and accelerated at the same time. One ball is dropped and hit the ground 5 seconds later. The other initially moves horizontally with 13 meters per second as in the figure below. When does the second ball hits the ground? And I'm sure again it should be 5 seconds, because again it doesn't matter if the ball is thrown or dropped, it must reach exactly at the same time. So yes, the answer is 5 seconds. Now number 54, which best describe why projectile move in a curved path. I guess we have answered this before. It's because of the gravity and also the horizontal motion. So this projectile has two kinds of motions. One of them horizontal, the other one is vertical. Now number 55, it says that a car accelerates from rest by 5 kilometers per hour second northward for 20 seconds, then accelerates by 4 kilometers per hour second southward for 10 seconds. What is the final velocity? This is a very straightforward problem, but you just need to be careful here. When you see kilometers per hour second, that is a unit to measure acceleration. Maybe many people are used to meter per second squared, but if you think about it, meter is a length, kilometer is a length, then second squared means second times second, which is time times time, and here we have also time times time because it's hour times second. So this unit is a proper unit to measure the acceleration. So I just need to use v final equal to v initial plus at, and the v initial is 0 because it starts from rest, as we can see in the problem, starts from rest, plus 5. I have to just put the acceleration multiplied by the time, which is 20 seconds, equals to 100 kilometers per hour. Now, because here when you multiply kilometers per hour second times second, the second will cancel out. Then you will end up with only kilometers per hour. Then we can just use this velocity for the second part, because this would be the initial velocity for the second part, because now the car decelerates, or the object, the car decelerates. So it's 100 minus 4 times 10. Now the 4 here is minus because it moves southward. It means it moves in the opposite direction, or decelerate probably. Then multiplied by 10, which is the new time, that gives you 60 kilometers per hour. It's plus, so it should be northward. Okay, so I hope you guys were watching these 3 videos about acceleration 1, 2, and 3. We have answered together about 55 questions, so I guess you guys should now be familiar with all these questions. As you may see, questions are mainly focused on the equations of motion, projectile motion, and the graphs like a velocity time graph, or a distance time graph, and so on. Okay, so I guess we can stop here. I'll see you next videos, inshallah. Thank you.